Okay, so welcome to day 6 of the restarted stats daily past paper program. I'm doing question 6 first because who doesn't like some pims and cons questions at the end of a long day of teaching? So let's do this one here. First one, we're looking at the number of ways we can arrange letters, which means we're looking at a permutation. I always like to space it out, even if we're getting pretty good at this by now. We've got 9 letters there, so there's my 9 spaces. The first letter has to be an R, and luckily there's only one R in this word, so that R has to be there. That means that we've got 8 spaces left. So 8 letters could go there, 7 could go there, 6 could go there, and so forth. So I know you guys are pretty good at this by now. I'm just going to do it for this first video all the way through. So that means that I've got 8 factorial ways of arranging everything else, except I've got duplicate letters. So we need to divide through by the factorial for those letters. So for example, we've got 3 G's there, so we'll divide through by 3 factorial for the 3 G's. And we've got, what else have we got? 2 E's, so we'll divide through by the 2 E's. And we've also got 2 A's. We'll divide through by those 2 A's as well. That leaves us with 1 T and 1 R. And so all I do is just quickly check that all of that adds up to 9, which it does. Because 3 plus 2 plus 2 is 7, plus the 1A plus the 1 T and the 1 R makes 9 letters. So if you work that all out, you get 1,680 ways for part 1. For part 2, same word, still all 9 letters, but this time the 3 G's are together. Both the letters A are together and both the letters E together. So this is actually easier than you think because all the G's look the same, all the A's look the same, and all the E's look the same. So if we just put them into one big block. So here's my one block, which is the 3 G's. Here's another block, which is the 2 A's. And here's another block, which is the 2 E's. Okay, and that just leaves me a T and an R to arrange as well. This one doesn't say which letter has to be first, so that they have to be together. So what I've got here is 1, 2, 3, 4, 5 objects to arrange. So it's 5 factorial. And you might be thinking, well, how come in this case don't we need to divide through by the duplicate G's, duplicate A's, and duplicate E's? Well, the thing is that normally when we make groups for our perms, we would also within the group work out how many ways we could arrange the objects within the group. So for example, he would say, oh, that's 3 factorials, that's 2 factorial, that's 2 factorial. But then with the duplicate letters, we could do that, but then at the end we'd have to divide through by 3 factorial, 2 factorial, 2 factorial, which just means it all just cancels out. So in this case here, we can just leave it as 5 factorial, and that's the answer. So 5 factorial comes out to be 120 different ways that you can arrange it like that. Yeah, so that's part 1, and that's part 2 done. See, we're moving through this pretty quickly. Part 3. The letters G, R, T are consonants, the letters A and E are vowels. Find the number of ways that you can arrange it if the consonants and vowels occur alternately. I feel like I've done this question before. Maybe it's just because we've done ones like this before as well. I'm sure there's one in an earlier past paper. So for this one here, you just have to lay out how many ways to do this. So it's going to go consonant, put a C below it, and then vowel, and then consonant, and then vowel, and so forth, all the way through until you've got 9 letters. 1, 2, 3, 4, 5, 6, 7, and 9, like that. 1, 2, 3, 4. Yeah. So that's enough vowels, and that's enough consonants. I'm just counting them, by the way. 1, 2, 3, 4, 5. Cool. Okay. We've got 5 consonants and we've got 4 vowels. So all that happens is when I look at the first spot, which is a consonant, I think, oh, how many consonants could go there? Well, there's 5 that could go there, right? And then how many vowels could go on the next one? Well, 4 vowels could go on the next one. How many consonants next one? Well, there's 1 less, so there's 4. How many vowels could go there? There's 1 less, so there's 3. So you're basically doing 2 factorials kind of side by side with each other. So it comes out to be the 5 factorial for the consonants and a 4 factorial for the vowels, right? So you would times those together to get all the ways you can arrange it. But we also then need to divide through by the duplicate letters. So same thing as before, we're going to divide through by 3 factorial for the 3 G's, 2 factorial for the 2 A's, another 2 factorial for the 2 E's. So if you work all of that out on your calculator, which I'm doing right now, normally I pause the video and do it, but I'll just do it right now. It comes out to be 120 different ways that you get for that one there. Okay, and so then on to part 4. I'm just going to move that out of the way, all the way up there. What are we doing? Find the number of different selections of the 4 letters of the word aggregate, which contain exactly 2 G's, or exactly 3 G's. So we've come across these ones before, and you've got to be careful. You can't just go around doing combination things because you've got duplicate letters. It is a combination type idea because we're talking about selections, not arrangements. So we're just wondering whether we have the letters or not. We don't care what order we've chosen them in, just have we got them or not in our little hands. Right, and we're after exactly 2 G's or exactly 3 G's. So I'm just going to list it out for you. So there's a scenario that's got 2 G's, and the scenario here has got 3 G's rolling around. Okay, so then in this scenario here, I want 2 more letters, right, to go along with my 2 G's. Over here, I just want 1 more letter to go around, and I don't want any more G's here. And we start with this one over here because it's a little bit easier. We just want 1 more letter that goes with the 3 G. So we've got 4 options. We can add to this mix either an A, or we can add to this mix an E, or we can add to it a T, and one more. Oh yeah, we can add to it an R. Okay, so there's 4 different selections that we can have. 4 different selections. And remember, they've got to be different, so there's no point using combinations and stuff because we've got duplicate letters, so we're basically going to list it out, really. So that's 4 for that one there, and then we need to work out how many over here we can get with the 2 G's. So you've got to think, what unique letters do you have left to play with? Well, you've got some A's, you've got some E's, some T's, and some R's to play with. You can't use that last G because you can only have exactly 2 G's in your group. You can have double letters if they're available. So, for example, there are 2 A's, there are 2 E's, but there's only 1 T and there's only 1 R. So I want to show you a method that I learned. It's actually from music, and I can't remember how I learned it in my degree somehow. But anyway, so we're going to start with the first letter here, and we're going to start making pairs. And the first pair that we can do is with itself. So an A can go with an A, an A can go with an E, an A can go with a T, and an A can go with an R. So you've got 4 combinations there. And then you go to the E, and the E can go with itself because there's 2 E's. The E can also go with the T, and the E can also go with the R there. And then that leaves you with the T, this last one here. The T can't go with itself because there's only 1 T, so all that's left is that T there can go with that R there. So what you end up with is 1, 2, 3, 4, 5, 6, 7, 8 combinations of letters. If you want to, you could list them all out. So you've got AA, AE, AT, AR, ET, and EE, ER, and the last one's TR. So you've got 8 there. And I guess it's just a diagram to help you do that systematically so you don't miss any out, because you are just selecting them. So once you've selected A and an E, that's the same as an E and an A, so you don't need to select it again, if that makes sense. So anyway, all up we've got 12 different ways that we can select 4 letters, which contain exactly 2 Gs and exactly 3 Gs. I was just thinking also for here, I guess the other way that you could have done it is to look at these 4 letters as being unique letters, which they are, so no duplicates, and gone with 4C2, which would give you 6 letters, and then just added on yourself the 2 duplicates, so the 2 A's and the 2 E's, so you made sure you had everything covered, and that would still make a total of 8 ways of setting those other 2 letters